Fantastic. Okay, so what else could I do with this? Well, let's suppose I wanted to know the distance from A to B. I wanted to know the distance from A to B. How could I do that?
Use the triangle principle.
Exactly. So there's a principle to do with triangles. Does anybody know what it's actually called? Named after a mathematician? Pythagoras. Yeah? There's a mathematician called Pythagoras. He didn't come up with it. He was just a really good teacher, and a lot of people kind of flocked to him. He wasn't a very nice man. He killed people because they believed in maths, and they sort of, yeah, anyway. Pythagoras' theorem, and so he really loved this theorem, and so then it became known as Pythagoras' theorem. But he didn't come up with it, like it's been known for thousands of years before him. Okay? So Pythagoras' theorem says that the length of the red line should be this side squared plus this side squared. Okay? Now I want to write this in some way. So the way which I do it is using the modulus sign. Okay? That just simply means distance. Simply means distance. Okay? Now actually, because I'm writing it as a vector, and you will notice that I kind of get into this habit, I tend to write it using two lines instead, because it's to do with a vector. Okay? You don't have to, but that's just how I tend to do it. Okay? So, this is going to be equal to, it's going to be equal to the square root of this side squared plus this side squared. Does that make sense? What does this come out as?
5.
5. Perfect. Okay? So this here would be my distance, or magnitude. So remember magnitude, we talked about it there, it's just the size. How long is that vector? And I can do that quite simply through Pythagoras. Okay? Okay, what else can I do with this then? Well, let's suppose now I know this, I want to come up with a unit vector. I want to come up with a unit vector. Now, what do you think a unit vector actually is? What is a unit? What's a unit? It's just one, right? So I want to come up with a vector that just has a magnitude of 1. That's all a unit vector is. It just has a magnitude of 1. So let's suppose I know that u is 3, 4. Okay? And I want to come up with a unit vector for u. In other words, I want to come up with a vector that has the same direction as u, so in other words, it still goes in this direction, but instead of going 5 along, because the direction of the length of that is 5, I only want to go 1. Okay, I only want to go 1. Okay? Now the way which I'm actually going to write this is I'm still going to use u, but I'm going to put a little hat over the top of it. Okay? So if I put a hat over the top of it, it just simply means the unit vector. Okay? So let's have a think. Okay? I still want to move in the same direction as u. In other words, I still want to move in the same direction as 3, 4. But instead of moving 3, 4, are you happy that u is going to move a fifth of the direction in each case? Does that make sense why? Because the magnitude of u is 5. In other words, the length of u is 5 long. So instead of only moving 5 across, I only want to move 1. Okay? Therefore, I'm going to move 5 times less. Does that make sense? So in other words, I'm going to move 3/5 and 4/5. Because instead of moving 3 across, I'm only going to move a fifth of that, hence 3/5. Instead of moving 4 up, I'm only going to move a fifth of that, which is 4/5. Okay? So in general, if I have a vector, let's say v, okay, and if I want to find, so let's say v is v1, v2, okay, how would I find the unit vector of v? Well, are you happy that all I would do is simply take the original vector, and divide it by the magnitude. Yeah, divide it by the magnitude. That's where the fifth comes from. So I'm going to divide all of that by the magnitude of v. Is that okay? Where the magnitude is simply given by, it's giving that thing squared plus that thing squared. So each of the component directions squared, square rooted. Is that okay? Is that okay with everyone? Okay, fine.